Okay, so now we're going to step it up a notch and start talking word problems. So 35. So now that we've learned to solve sides, angles using both laws, we can start solving word problems. In general, you should include the following as part of your solution. So this is just a guideline. Some students like that. They would like to know A, B, C, do it this way, but we'll be drawing a diagram, assign letters to each angle. So if it's, for example, a tower, then call that angle a T, right? Or something that kind of is relevant in that situation. You can go A, B, C as well, but I tend to use letters that pertain to the situation. If it seems that you're stuck, start solving for sides that you can, and then move in to the unknown side or angle. So sometimes you're like, I can't answer it right now. It's like, wait a minute, back up and see, like, what can I do? Can I maybe solve for something else in the meantime and then move in, right? So that's my suggestion to you. Show how you set up and solve your missing dimensions, obviously. Round final answers to two decimals, including angles, because I know that probably, I feel like an IPR, sometimes they make you round angles to the nearest degree. We don't do that because grade 12 applied, it's always two decimals. Remember to check if your answer is reasonable. That is a big one. Right? If you're in like 30 kilometers, 40 kilometers, all of a sudden your answer is 1,000, you should probably check, right? You should check, does that make sense? Okay, so that's some definition and terms and stuff that you will need would be angle of elevation and angle of depression. Your teacher should have talked about that in the past, right? So I will just give you the best shortcut version. So this is a person, A, right? Math, yay, math. So I always want you to think of a horizontal. You will make up the horizontal if it's not there. This is the horizontal. Okay, and then there might be something up here, flying up there, or there might be a bug down on the ground. Okay, so if you're from the horizontal, you're looking up, right? If your line of sight is fixated on that bird, that is what we call the angle of elevation. So I'll go arrow up like this. Okay, this is the angle of elevation, page 35. Alternatively, if you're looking down, okay, that angle you start measuring from the horizontal downwards, so your line of sight is going to that, so that's the angle of depression. Very important, okay? But you must come up with a horizontal. It's not always obvious. When you're on the ground, a lot of students see, yeah, the ground is my horizontal, I'm looking up. But when somebody's up on a hill, you're flying or whatever, and you're looking down, students don't remember that there's an imaginary horizontal. So if you're flying a plane, imagine that there's a horizontal, and then you start measuring from there down to whatever you're looking at on the ground. Okay. Supplementary angles. Angles whose sum is 180. There you go. It's right to complement someone. 90, right? Complement. So it's 180 is a supplementary. So how's that going to be beneficial? Here it is. You might have a situation. Let's just draw a straight line like this. And let's draw a nice tree here. Oops, I'm off. Sorry, guys. You can always let me know if I'm off a little here. So right, that's your tree. So let's say there's a person standing right here looking up. And let's say the question says, hey, the angle of elevation for that person looking up is 40 degrees. And it could be that another person is standing away from the first one, somewhere over here. And the angle of elevation would be, let's say, 25 degrees. I hope you see a bunch of triangles there. You see them? There's one here. This one. There's one here, potentially. What would this be? The height, right? That'd be the height of the tree, even though I didn't quite go to the top of the tree, but just disregard that. This is for illustration purposes. How can you possibly use this one to get you an angle in here? And I think you're all seeing it, right? This is a straight line. So this means that this must be 140. So just like that, you brought an angle inside this triangle here. So these are supplementary. So all of these things will be taking place at some point. Guy wires. Do you know what guy wires are? No, nobody? Nobody? No brave volunteer? Okay. Once I tell you, you will know for sure. You know when the hydro poles like this, the wires run, they have like a cable supporting it? That is called a guy wire. Don't ask me who came up with that name, but that's a guy wire. So antennas, poles, stuff like that, they have guy wires. Sometimes they have more than one, right? Antennas will have like all around them, will have a bunch, sometimes from both sides. If you walk out, if you go out Sisler and leave, what is it, Shaughnessy over there? Yes. There's a guy wire there, one of the hydro poles. So maybe today you'll look at it and say, yeah, I know what that is called. And that's a fun fact for the day. But some questions do say a guy wire makes an angle of 40 degrees with the ground. You know now, okay, this is what's happening. Right? There's some structure and a cable supporting it, and the angle goes there. There we go. Pythagorean theorem. I'm just going to give you the shortcut version here. Pythagorean theorem only works with right triangles, but it's very handy when you know 2 out of the 3 sides. Okay, only works. Do not use it with anything that isn't right triangle. Okay, only works with right triangles. That's first observation. You need 2 out of 3 sides. Okay, that's the only way this thing works. You need 2 out of the 3 sides, and it has to be a right triangle. How do you know it's a right triangle? The box, right? Or the context tells you that this is the height, for example. We know that the height is measured with 90 degrees with respect to the base. What do we call this side across the 90? Starts with an H. Hippopotamus? Hypotenuse, right? Hypotenuse. And what are the other 2 called in this context? Opposite adjacent. We're not going to talk about opposite adjacent. I don't want to go there. SOHCAHTOA. We're not going to use SOHCAHTOA. But when you're using Pythagorean theorem, these are called legs. You remember that? Have your teachers ever? You are right. They are called opposite and adjacent when you're using sine, cosine, tan. But we're not going to go there. Okay. So leg. You can call leg 1, leg 2. I just call them legs, right? So bottom line, if you want to find the hypotenuse, you got to go hypotenuse squared is equal to leg squared plus leg squared. Just like that. That's basically the theorem. It says if you were to take the longest side squared, that is equal to squaring the other 2 legs and adding them up. That's what the theorem says. I know you used ABC, but that's another way of looking at it. But this is really what it's saying. From there, we can deduct that to find the hypotenuse, and these are the ones I would like you to use. To find the hypotenuse, you simply square root what you get when you add the squares of the legs. Or if you would want to find one of the legs, it doesn't matter, you would have to take the hypotenuse squared and subtract the other leg squared from it. This is really where it comes down. So I use this original formula. This is the theorem to tell you, hey, if you want to know the hypotenuse, this is what you must do. If you want to know one of the legs, if you don't know what it is, just go hypotenuse squared minus the leg that is provided. Squared, always squaring, okay? So that's basically, we won't use it very often, but if it does, if the opportunity presents itself, I might resort to it, okay? I might. So let's keep going. I think now we can actually start with our first problem. Solving word problems. A radio antenna is supported by two wires on opposite sides, two guy wires, by the way. The wires are anchored 60 meters apart. When something is anchored, it's driven into the ground, right? It's anchored there. That's where it touches the ground. They're 60 meters apart. One wire has an angle of elevation of 62. Why don't we highlight these important pieces, right? 60 meters apart. One has an angle of elevation of 62 degrees. The other has an angle of elevation of 75 degrees. It just says one or the other. It doesn't say the one to the left or the one to the right. It doesn't really specify, but it does say on opposite sides. Do you see that? Why is that important? Because, and I'm guilty of not being very specific sometimes in this booklet, but on the test, I go very specific. So sometimes when I assign a question, you might be like, how exactly, you didn't tell us, maybe I'm missing a word there. And I will try to catch that and give you what it's supposed to look like. But these are the scenarios. Scenarios possible, right? You could have an antenna, and this is the ground here, and you could have both on the same side, right? You could have two wires like that on the same side. Wire 1, wire 2. Same side, right? Of tower antenna. That could have been a scenario, but this one is clearly saying that they're on opposite sides. So this is just an aside. This is saying opposite. Maybe I use a different color for that to really drive that home. So let's sketch this scenario, and I will give you marks for sketching the scenario and interpreting it. If you get that wrong, you'll lose marks, of course, but then you will still get marks for the process that follows. If your diagram, if the mistake results in a lot less work, you will lose more marks down the road, because I just don't think it's fair. Sometimes your mistake makes it very easy to solve for what I'm asking for. Then I take off more. But if it's just a slight mistake and you still have to do a lot of work after that, it's just for the sketch that I subtract marks. So here we go. A wire, an antenna supported by two wires. So naturally you should be thinking, this is the ground. And let's put our antenna right here. And we have one wire on each side. So which one is going to be, like, if this is 62 degrees, that's the angle of elevation with one wire, then the other one should be a little bit closer to it. Wouldn't you agree? because the closer you are to an object, the more you have to like raise your head to look to the top, right? Your angle gets sharper. So that helps sometimes to make it a bit more realistic. So they're supported here. And we are told that this distance down here is 60 meters. We have three pieces of information for that big triangle. You see that? We've got two angles, got one side. Now, the antenna makes a 90 with the ground. That is something we would just expect, right? That is just an industry standard. You wouldn't want to have a leaning tower, right? It's just not cool. So we're expecting that to be a 90. So yes, you have two 90-degree triangles there. You have two right triangles. But mark my words, don't zoom in right away to those. Don't go into those right triangles right away. Focus on the big one. Okay. So have I labeled this correctly? I think so. Everything is there. All right. So this would be done for the sketch. Let's do B now. The length for each wire. Maybe now I should mention, let's differentiate between the wires. So I'm going to call this W sub 1, and this is going to be W sub 2. And maybe for this angle up here, so this is my tower, it continues, right? But they touch here. Let's call this A. So that whole thing here is going to be called angle A for antenna. So we're going to do wire 1 first. What can we use to solve this triangle? Which law should we start with? Are you saying sine law? Sine law? Right? If you zoom out, forget about this line sometimes. Forget about it. Like just look at the big triangle because it's there. So we need to figure out, find angle A first. And I'll just say big triangle. Let's do that. Angle A is 180 minus 62 minus 75. And that is 43 degrees. Very important to our operation, right? I will, I think I'm gonna highlight that and show you where it is on the triangle, right, to make sure it's the whole thing. You can write it in even. I'm gonna write over that antenna line there. So there's my 43, great. Now I have a pair. Now I have a pair, so sine law. So let's go ahead and do this, sine of 43 degrees. And this is where you should come in and just, shouldn't be a problem at all. Except for if we're doing W1, if that's the side we're trying to find, then we have to use 75. Sine of 75, that is. And let's solve that. That gives you 84.98. By the way, which of the two wires is going to be longer? Which one has the biggest angle across from it? 75, right? So we expect this to be longer than this one. So one more time. W2. I'm going to start with the same pair. Sine of 62 degrees over W2. You can call it A and B, X, Y, whatever you want. It's okay. W2 is 60 times sine of 62, sine of 43. W2 would be 7768. And you notice that I'm going a little faster with this step because I have a strong feeling that is not the problem. The problem is going to be setting up, and so this part here is going to be the problem. All right, so we found the length of each wire, right on. So this is B. Next, we have calculate how far up the pole the wires are attached. So how high up the pole? What is this? What would we call this based on what we've done so far? That'd be the height of the triangle, right? The height of our triangle, not of the tower, but of the triangle, which is right closed off by the wires. So I'm going to do that here. C height is equal to, I'm going to go with W1 multiplied by, you have to multiply the slant, just to reiterate, this slant is touching 62. So you have to multiply it by sine of 62. That's the shortcut way of doing that. And that gives me 7503. That's how high up the tower they're attached. I'm going to add D to this just because I can. I feel like I've used up too much space here. I don't think we'll. You think you can fit in a short sentence here? If you can, do it here. If not, add it somewhere over here where we're going to solve it. So D, what if I asked you the distance between antenna and wire 1? Could you determine the distance between the antenna and wire 1? Is that small? Sorry, I'm going to zoom into that. It's just because I don't have a whole lot of room. Really, it should read, what's the distance between the base of the antenna and wire 1, like where it's anchored? So it's along the ground. That's what I'm asking here. This distance right here. That's what I'm asking for. So why don't we do this? We're going to call this side X. Okay, put that in brackets. And I'm going to put a little X here. So from here all the way to there. That's what we're interested in. The reason I'm doing this is to bring in Pythagorean theorem there. So let's solve for that, because if you think about it, this is a right triangle. We know wire 1, we know the height of this triangle, so we have 2 out of the 3 sides. So let's do that here. D, I'm going to make a little sketch here. This is 75.03. This is 84.98, and this is X. This is leg, hypotenuse. Hypotenuse is always across the 90, okay? I'm going to zoom into that corner because I get it that it's a bit small here. There. If you want a leg, you need to go legs. Leg is equal to hypotenuse squared minus leg squared. In other words, to find x, we just take 8498 squared minus 75.03 squared. And this is going to be crammed here. This, if you plug this in, you get 1592.0995. Sorry guys, this is too small here, but this is 3990. Does that make sense? Pythagorean theorem? Okay. Let's box that off too. I was gonna add an E, but I'm not gonna do it because I know you're already giving me the looks. Stop it. What if, let's just do a mental exercise here. So we now know, what if I asked you, what is the distance between the antenna and the second wire? Like from here to here. Is there a quick way of doing that now? You could just take 60 and subtract x from it, and then you have that. Okay, so don't overdo it, right? Like if you can do it quickly, do it quickly. Okay. All right. So I mixed everything up here. So Pythagorean theorem is like a blast from the past, right? But it won't come up very often, but sometimes it's there for you to use. And you could have technically used sine law again with this one that you cut up, because you know this angle here, look up on the screen, you know this angle, so you could easily find that angle. You have a pair, and you could have gone sine of this angle over x and used sine law, but I think it's a little bit more, it's more work in my opinion. So to be honest, there will be plenty of times where you will be looking at my key and you will have done it quite differently. I actually encourage that. I don't have a problem with you doing it differently. And I might give you steps and you might like, I don't need those steps, I do it this way. As long as you show me your work, we're in business. Okay, what I want you to do, we're not going to focus on solving right now. I want you to look at 37, 38, and 39, and I just want you to sketch the scenario. That's all I want you to do for now. The solving part, we're going to do that in a bit. But this is the one case where I need to tell you, I need to, on 37, I need to give you a bit more information there, I find, because students come up with all different kinds of interpretations. So come with me to 37. So Amanda's enjoying a hot air balloon ride over Winnipeg at a height of 2,500 feet. She spots the forks at an angle of depression of 34 degrees. And at the same time, she spots Winnipeg's tallest building, the Artist Reed building, at an angle of depression of 27. Can I just say here, imagine the hot air balloon up in the air, looking out at the same, towards the same direction. It's not like you're seeing a building there and you're turning around to see another one over there. Just imagine you keep your face the same way. So try to interpret that. How about we do 37 and 38 for now, and then I'll take it back from you, and I'm curious to see how you do. Give it a try. I honestly, just give it a try. If you get it all wrong, it's not a big deal right now. So sketch 37, sketch 38, read it and interpret and put as much information in there as possible, okay? Make sure you use pencil. Okay, here it is. I'm just gonna do 37 real quick because I see some, and rightly so, you're not experts yet. but I really appreciate you trying because it lets me see right where you're at. So Amanda's enjoying a hot air balloon over Winnipeg with an altitude. What's altitude? It's a height. That's the height of the balloon, height above the ground. She spots the forks at an angle of depression. This is very important. It's an angle of depression, so that should tell you a little something about what's going to happen. And at the same time, spots the artist read at an angle of depression of 27 degrees. Sketch the scenario, include all labels and measurements. So let's imagine, I don't know, I'm not really good at drawing, as you can tell, but this is the hot air balloon here. Okay. Anyways, and so you have to imagine, right, from that hot air balloon, there is a horizontal because we're going to have to come up with angles of depression, right? So that's your imaginary horizontal line. And then what do we have? We have something on the ground here. All right. So this is the ground. This is the horizontal line. This is the ground. And we know that the altitude of this hot air balloon, I'm going to make it dashed as well for now because it's at a 90, but we know that that's 2,500. I shouldn't have started with this one probably. So there's the height, there's the horizontal. And so the first, it's angle of depression of 34. So you start from the horizontal, you go 34 degrees. That's approximately, right, somewhere there. That is 34. And then the other one has an angle of depression of what? 27. So it should be smaller than that one. So 27, let's say we go right about there. So I'm going to make that angle there. So this is 27 here, 27. So you have 34 going all the way to this line, and you have 27 that goes to that line. So the first one, the 34, is the forks, so let's call that F. And the other building at a 27-degree angle of depression is the Artist Reed building. And let's call this H for hot air balloon. So there you've sketched it. Everything that, all the numbers that they provided appear. They appear on there. Okay, I'm not going to solve this today, but this is going to be your homework. You're going to have to sketch a bunch of scenarios. Okay, so I'm just going to flip through the pages. I'm going to say 37 to 38. Okay. So homework, I'll tell you right here. Homework, sketch, write this down. Sketch 37, page 37 to 39. But I will say this, solve page 38. That's the one I want you to actually try to solve. So sketch 37 to 39, but actually try to solve page 38. Okay. 37 is already done, so really you just have to do 38 and 39. Thank you guys.